Okay, so in this video I'll be discussing slope and graphs of linear functions. So it says finding the slope of a line from its graph. Well, first of all, our definition of slope is given here. The slope of a line is a measure of its slant or steepness. All right, so it's literally a characteristic of a line that's important. Different lines have different slopes. You can see in the problems down below, 1, 2, and 3. And so it's an important description of a line. You may recall from the past that slope is equal to rise over run, or the change in y divided by the change in x. So on number 1 here it says find the slope of each of the following lines. So on these first 3 lines I made it pretty nice on you guys because I gave you some points that are obvious. Notice these are at nice positions where the lines cross, so they're going to have nice integer values. So this point is the point 1, 1. Those are the kind of points you want to use when you're finding slope. So for example, this point here is not at a nice point, so you got to watch out for that. You want to choose 2 what I call nice points, and then you do rise over run. So let's go ahead and do this first problem here. So rise over run here. Now I'm going to start on the point, or with the point on the left, and notice I need to rise up to get to the level of the other point. And since we're going in the positive y direction, we would say that's a positive 2. And then we're going to run, and when we run, we go in the x direction, and going to the right 3 here means our run is a positive 3 since we're going in the positive x direction. And so the slope of this line is 2/3. And in fact, if you went up 2 again and right 3, up 2 again and right 3, you would keep landing on the line. We could find as many points as we wanted to. All right, so I just wanted to say here that, I went from left to right, and that's, what I always try to do when I'm doing math is to try to be consistent. So I'm going to go from the left point to the right point, but some of you might have said, hey, what if I started at the other point? Well, if I started at the point on the right, then my rise, notice I'm going down 2, and so the rise is negative 2. And then I'm going to go left 3. Now that's the negative x direction, and so that would be negative 3. And so notice I get 2/3, same answer. So it really doesn't matter which point you start at, but just to be consistent, I would go left to right. Not to mention slope is read from left to right. That's how we read slope. In fact, if you look at this line here, going from left to right, it's rising. And so it makes sense that it has a positive slope. Whereas if you look at number 2, that one's falling as you go from left to right, so I'm expecting a negative slope. So let me give you these 4 cases here. So for the first one here, we would say this has a positive slope. From left to right, it's going up. And then for this next one here, from left to right, it's falling or going down, and so this line would have a negative slope. Now this line has a slope, well, it's nice and flat, and so we say that's got a slope of 0. And then finally, this line here, this last one, it goes straight up and down. It's actually got an undefined slope. If you think about it, you can have lines that get steeper and steeper that are positive, and the same thing can happen with the lines on the other side that are negative. The one in the middle, the slope is undefined. All right, so vertical lines are undefined for slope, and horizontal lines have a slope of 0. All right, so let's go ahead and move on to number 2. I would encourage you to try that one and then watch the video. All right, so we have rise over run, and notice we go down. What is that? 1, 2, 3, 4. And so since we're going in the negative y direction, that's why it's a negative 4. And then we're going right 2, and so that's in the positive x direction. That would be 2. And this simplifies to -2. One thing that you'll notice, if you're always going from the left point to the right point, your run is always going to be positive. So again, it's nice to be consistent when you do slope and a lot of other math stuff. All right, so again, I would encourage you to try 3 and then watch the video. All right, so we have rise over run is equal to, so let's see, from the left point here we go up. It looks like that's 6, and we went in the positive x direction, so that's 6 over our run, which is, well, let's see, 1, 2, 3, and so that's in the positive direction, so that's 6/3, which reduces to 2. Now I could think of that as 2 over 1. Notice we could actually go up 2, right 1, up 2, right 1. And so you can see that a slope of 2 definitely, you rise 2, you go 1 to the right, you're on another point on the line. And so that is our slope. Let's move on. All right, so here you'll notice I didn't give you the points. So I would encourage you to see if you could find the slope of these 3 lines. Just keep in mind, you need to find what I call nice points, that are where the vertical and horizontal lines cross. And it can't just be close, it's got to be exact. And you should be able to find at least 2 nice points on each of these graphs. All right, so let's see how you did. So here we're going to rise over run. So let's see, we needed to find a couple of points. Looks like we have one at -1, -2, and another one at 3, -3. And so now we'll do the rise over run, going from the left point to the right point. So we're going to have to go down 1, so our rise is -1. And then we're going to go right 4, and so the run is +4. So our slope is -1/4. On number 5, let's see, again, it's rise over run. We've got a point at -1, -3, and it looks like at 3, 2. So our rise, going from left to right, looks like we're going up 5, and so that's positive y direction, and then we're going, it looks, let's see, what is that, 4 to the right, and so we get 4. Now I just wanted to mention, you'll notice I'm using these little bumps to kind of show you how I'm getting to where I go to my second point. But normally I just count how many squares I go, or how many units, but you don't have to make these little marks, but for some people they're helpful, so I like to use them. All right, on number 6, hopefully you looked at that one and you said, oh, Mr. Smith said if a horizontal line has a slope of 0, I know this one has a slope of 0. Now, if you wanted to, find a couple of points, let me go ahead and write the formula down. We have a whole bunch to choose from here. I'll choose these two, 0, 2, and 2, 2. And so my rise, notice I don't rise at all, and so the rise is 0, and my run is 2. And of course, 0 divided by anything is 0. And so we do get 0 as a slope there. All right, so, excuse me. So Roman numeral 2, now we're going to talk about finding the slope of a line given 2 points. Notice now we don't have the graph. So first of all, when we're talking about slope, you should be able to look at a line that's been graphed and determine what the slope is visually using rise over run. And so now we're going to talk about when you don't have a graph and you just have the 2 ordered pairs. And so it says here, given 2 points on a line, we're calling them x sub 1, y sub 1, and x sub 2, y sub 2. And really all that means is we've got the first point here and the second point here. So like y sub 2 is just the y value of the second point. That's all that means. Sometimes those little subscripts will bother people. So it says if you have these 2 points, the slope of the line is m equals, so notice m stands for slope. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So basically, remember, slope is rise over run. So we're getting the rise by subtracting the y values of our points, and we're getting the run by subtracting the x values of our points. Let me just show you this. This is, excuse me, on number 4, I'm going to graph number 1 from above and show you here. We had done this one, and we got the rise was 2 and the run was 3. And so what if we didn't have the graph? Well, let's go ahead and label our points here. And we can see how we can get the rise and the run by just using the points. Notice when we rise, the rise was 2, and we moved in the y direction, or vertically, and if you subtract 3 minus 1, that's where you're getting that 2. It's just, you subtract the 2 y values of the points. And similarly, notice our run is 3, and now we're going in the x direction, and we find the 3 by subtracting our x values. 4 minus 1 gives you the 3. And so this is not some magical formula. It makes sense in looking at what we're looking at here in terms of slope. All right, so number 7 here, I'm going to go ahead and write the formula. And this is what I call a plug and chug situation. I have 2 points. I'm going to call this my first point, and the 3/8 is going to be my second point. So 1, 2 is my first point, 3/8 is my second point, and now we're just going to plug in the numbers. So y sub 2 is 8, and we're going to subtract y sub 1, which is 2. So we're just subtracting the y values of the 2 points. And then we're going to subtract the, x sub 2, which is 3, minus the x value of the first point, which is 1. Now notice we always start at the same point. We did 8 minus 2, and then 3 minus 1. So you need to make sure you're starting at the same point. But if you're just plugging in the numbers based on what I put up above, with x1, y1, and x sub 2, y sub 2, you're just substituting in those numbers. So we get 8 minus 2, which is 6, over 3 minus 1, which is 2, and so our slope is 3. So I would encourage you to try 8 and 9, and I just warn you, the formula uses subtraction, and sometimes you'll be subtracting a negative number. So be careful with your arithmetic when you do that. All right, so here we have our formula, and let's label our points. And so it's y sub 2 minus y sub 1. Oops, I didn't label the other one. So that's going to be 3 minus 4 in the numerator. And then x sub 2 minus x sub 1, that'll be negative 1 minus negative 3. So in the numerator, we're going to get negative 1, 3 minus 4. And then we have negative 1 plus 3. Subtracting a negative is the same as adding the positive. And so that would be 2. And so our answer is negative 1/2. All right, so on number 9, we've got our formula. We'll label our points. And so we have y sub 2 minus y sub 1, which is negative 6 minus negative 1. And we got x sub 2 minus x sub 1. That's going to be negative 2 minus 1. In the numerator, we have negative 6 plus 1, which is negative 5. And negative 2 minus 3 is negative 3. And of course, a negative divided by a negative is a positive, so we end up with 5/3. All right, and so if we're given 2 points, we can use the slope formula to find the slope. And the other thing I just want to mention here is this is a formula that you need to get to know by memory. It's something when you move on to later classes, it would be a formula that they would expect you to know. All right, let's move on to the next problem. So applications of slope. Number 10 here, it says find the grade or the slope of the hill. tip. The grade is written as a percent. Now you're also going to have a problem when you do your homework where you have pitch, like the pitch of a roof, and it'll be similar. You'll give your answer as a percent. And so what we're really looking at here is just, whoa, I went way too fast. Let me back that up. All right, so our grade is its slope, or rise over run. And so here we've got 2 points, one at the bottom of the hill and one at the top. Excuse me. And so notice we're going to actually rise 16 yards, or 16, and run 200. And so it's going to be 16 over 200, which is 8 hundredths. And if you change that to a percent, we move that decimal 2 to the right and put a percent symbol in, we get 8%. Now 8% is actually a pretty large grade for a road. It's not intended for like big trucks and that kind of stuff. That's pretty big grade. Now next here we have a problem where we're going to deal with rate. It says definition, a rate is a ratio of two quantities with different units. For an example, you might have miles per hour or miles per gallon. These are ratios of numbers where the units, there's two different units. So that's the idea here. And so rate of change is equal to change in y over change in x, which we also said is rise over run. And so let me go ahead and write that down. So that's our rate of change. So notice we have 2 points here, and so we're going to subtract our y values in the numerator, and we're going to subtract our x values in the denominator. And just to keep things positive, we'll start with this y value here and subtract this one here, although it'll work no matter which point you start with. And so our change in y is going to be 2,700 minus 2,400. And then we'll subtract our x values. We get 2011 minus 2004. And so notice that's years. Oops, I forgot to put that in. So in the numerator we have money, and in the denominator our unit is years. So when you subtract those numbers in the numerator, you get 300. In the denominator we get 7 years. So we're saying the rate of change is $300, or $300 more in 7 years. Well, it'd be nice. We don't really talk that way in terms of periods of 7 years. I'd like to know how much it's going up per year. So let's divide by 7. So that's $42.86 per year. Notice I'm rounding to the nearest cent. But normally we would write it like this, $42.86 per year. We either use a slash, or sometimes people will just write PER. All right, so that's how you will find rate of change with these types of problems. So let's move on to the next problem here. We've got Roman numeral 4, the slope-intercept form of a line. So definition, the slope-intercept form of a line is y equals mx plus b, where m is the slope and 0b is the y-intercept. So we're saying m stands for slope, and b tells us here where the y-intercept is, or what it is. So that's 0 comma b. And we'll get into intercepts in the next section, so I'm not going to go into a lot of detail here. I mean, the main thing you can see about a y-intercept is it has an x value of 0. All right, so but the thing is, these are pretty easy to do because they've all, well, the first two have been solved for y. Notice on number 12, it is in the form y equals mx plus b. So our slope here is -4, and our y-intercept is 0, 9. Again, this is my b value, and that's going to go right there. Now that's not really surprising, because if you said, okay, y equals -4, if I let x be 0, which that's what we have here, plus 9, then notice that's going to be negative 4 times 0, which is 0, plus 9. And so when you plug in 0 for x, y does equal 9. But you really, all you have to do is look here, and you'll always know what your y-intercept is. All right, so you should go ahead and try 13. The only difference there is it's in function notation. Remember, f of x is just another name for y. And number 14, you're going to have to solve for y first. All right, so let's see how you did. So this is the function form of our linear function. And in this case here, you can see our slope is 2/5, and our y-intercept is 0, -5. Now, number 14, I can't tell just by looking here. I'm going to go ahead and put it in slope-intercept form so that I'll know the slope and the intercept. So I'm going to subtract 3x from both sides. I'm trying to get this term by itself so then I could solve for y. And so I get -4y is equal to, now I could write 8 minus 3x, but we normally, well, you'll see in our formula the x term comes first. And so that's why we're going to put our x term first. So we have a -3x, and we have a positive 8, so we'll write that as plus 8. And then now we just need to divide each side by -4. So on the left, we're going to get y. And you're going to have, we can break this fraction into 2. Whoops. And so we're going to get -3x over -4 plus 8 over -4. That'd be plus -2, which we'll write as -2. Of course, -3 divided by -4 gives you the 3/4. And so now we've solved for y, and it's easy to see what our slope is, and also our y-intercept. We have y equals 3/4 x minus 2. So our slope is 3/4, and our y-intercept is the point 0, -2. All right, and that's the end of this video.